Okay, hello class, weekly update. So at the end of module 2, a few comments. So thanks for the folks that submitted surveys, Michael, Lucas, Sam, Peyton, Lily, and I feel like I'm forgetting a few folks. Super helpful. Again, so I got to see some things that, and also from your homework, some things that you guys are doing well and some things you're struggling with. So one comment was that gradient vector fields, we're going to do a whole lot more of those in book 3.5. So if that was a little fuzzy for you, we're going to come back to vector fields. Book 3.5, an entire chapter, we're going to hit vector fields. So we'll see those again. Directional derivatives versus gradient. So a few homeworks, Dropbox submissions, I noticed people made some comments that they're still fuzzy on those ideas. Surveys said that, and then seeing from the homework. So I've added at the end of module 2, another video that it has a really good tech tool that I found, one that I didn't have earlier. So a new one from a website called Math Insight that shows the visually the R3 surface and the contour map, directional derivatives, gradients, partial derivatives. So if you're struggling with that, please go back and check that video. It's a shorter video. I think that'll really help clarify some ideas for you. Okay, another comment, I also at the end of module 2 put in an option, or sorry, the end of module 3, so the one you're doing now, put in an optional practice midterm. We're not having a midterm, so don't freak out about that, but if you wanted to see where you're at, because we do have a final exam, just take a look at the problems. And what I did, I actually chose, I asked my colleagues who teach 221 regularly to give me their exams, and I pulled problems from those. We teach things in a slightly different order, so I just pulled some problems from their different exams, and you can take a look at those, and you'll see because they're the other 221 instructors, they tend to be much more calculation focused. So if I was making a midterm, and I am making your final, it'll have an even mix of the concept questions and the calculation. But I feel like we get plenty of practice with the concepts that are in your journals, from the quizzes, from the lectures. So if you want to see more practice of the calculation ones, and that's the part you're maybe not as confident with, check out that practice midterm. Print it out, at least take a look at it, and if you want to submit it, maybe we'll get someone that does a beautiful job and makes an answer key basically for us. And if that happens, then I'll post it, and that would be a nice service to the class. And of course, you can always go through those and check your work with tech tools. Okay, then the challenge problems. Really nice job on those. I got to see a couple, so most of the groups did challenge number 3, which was you're on a surface and it asks you some questions about steepest ascent. It also asks you questions about directions of no change. And then other groups, a few groups, handful of groups did, actually maybe 3 groups did challenge number 4 on the golf course design, which was really neat to see those. And I want to show a couple of those here in a moment. So just a summary, if you didn't do challenge number 3, one of the key additional new information takeaways was that suppose we have a surface, so let's just again visualize a circular paraboloid facing down. And so this downward facing circular paraboloid, you're at some point on this surface, and of course we know about the gradient gives us direction of steepest ascent, but what if we moved in a direction that was actually perpendicular to that gradient? What is that? And so almost all the groups got this. I think there's only 1 or 2 that struggle a bit with this. That would be the direction of no change. You're actually just moving around the surface at the same z-value, the z equals k that you're at. So these directions of no change don't get as much discussion or as much press, I guess. And so I asked a few questions, and it was really neat to see, I think it was, let's see, group 2. Yeah, Lily, Ethan, and Dallas did an upgrade 4 and talked about all the different places where you could use directions of no change. And they talked about, like, for accessibility, folks that say you're in a wheelchair, like you do care about what are the steepness of the grade here, and you'd like to move in campus design or building design in directions of no change. So really neat work on that. And then one of my favorite comments from that one, I think it was Dallas, said that as a group they worked together hella well. So that's awesome. Good job. Hopefully all the groups are working hella well together. And okay, so then a couple other comments on those, a couple other shout outs. Let's see. Oh, group 9, which is the John Tates in the making. Really nice job on the level ups, and it was a great, very clear report. Group 8, you had excellent explanations. I thought that was really well done. Group 10 is Nate, Haley, and Jeff. It was very succinct and to the point. And group 13 was Christian, Zach, and Colin. Oh, and maybe Charles. Oh, that's right. You guys did they did a proof of why the direction of no change on this surface, the circular paraboloid facing down, steepest ascent, steepest descent, direction of no change, and they did a proof of why that had to be perpendicular. So that was nice to see. Okay, and then group challenge 4, there were 2 groups I wanted to talk about. Okay, so group 12 is Eddie, Kyra, Michael, and Cameron F. So I do actually want to share the screen and show some of these. Let's see. So group 12, here we are. Okay, and one thing I really liked about this is, again, they're very clear about whose contributions. They did a really nice job labeling that and laying, you can see their thought process and laying it out. And then this was really neat. I think this was Kyra here, because I'm pretty sure this was her color. She played around in CalcPlot 3D until she got a function that made a golf course design that she really liked that would have a contour map. And then the rest of the team helped fill in and wrote some comments about the level curves. I think they put in a sand trap or something, sandbar, and showed these different vectors, the gradient vectors at different places. Oh wait, this might be their notes. And then we get to, oh, and then she even drew a picture, colored in. So let's get to, I think those are all their notes. Okay, here's the final report, which they always do a beautiful job with the graphic design and making it look so clear and easy to see, labeling things. This was the contour map, these are level curves. The equation that they used that created this was really cool to find that. And then they started labeling these gradient vectors on there, steepest ascent, steepest descent, show that how this compares with golf applications. And then again, Kyra shows this beautiful sketch of what the course would look like, and then the actual CalcPlot 3D image that they used. Okay, so great job on that. And then another group that I really thought was nice on this one was group 9. Lane, is this the one I'm thinking of? Oh, that's you guys already. Group 9, let's make sure I got this one right. Okay, got my numbers wrong, 7 maybe. Can't read my own handwriting. Yes, okay. So let's get to their final report. What I thought was a really nice, this is useful for, so they drew, I believe this is probably Lane, I think has the ability with this software, you draw these really nice pictures. And then I think Jenna this might be Jenna's handwriting, came in here and, can I zoom in on this? This is just a awesome study guide. Right here is like everything you needed to know about chapter 2. They have underlined, like, you know, what are level curves, saddle points, how you knew they were saddle points, steepest direction, critical points, that because the partials were 0 here, gradient vectors, gradient vector fields, they show a little section of gradient vector field, path of steepest descent, I think it was here, going into the valley of the hole. So really nice summary, and I think that's going to serve definitely that group and that group of students, but also other ones. So if you do want to shoot them an email, this was Jenna, Sam, and Lane, group 7. Shoot them an email, ask them if you can see their report. And again, they've done a lot of work here that helps you study guide for the final exam. Okay, so let's stop the share. See if there's anything else on this. Okay, I think that's it. So again, check out those videos from at the end of module 2, directional derivative versus gradient. It's a short one with a really cool tech tool visualization. I think it's really going to help. And if you want to take a look at the practice midterm, otherwise have fun with module 3. I think there's some really neat applications here.